Hi everyone, so today we're going to be talking about solving quadratics that are in vertex form. Now, we've been spending a lot of time this year solving quadratics in standard form, and you are very comfortable with that. So here's an example of that. I give you y equals x squared plus 9x plus 20. Remember, this is a function because it has an input and an output, an x and a y. So if I want to solve it, I first have to set y equal to 0. Okay, and I'm going to solve by using the method I know so far, which is to solve by factoring. I'm going to put the 0 on this side. So we're going to write it in factored form. Factored form, we're looking for the factors of 20 that multiply to 20 that add to 9. So it looks like x plus 4 and x plus 5 equals 0. And then we're going to use the zero product property to set each factor equal to 0, giving me negative 4. And giving me negative 5. Now, the most important thing for you to remember is what your solutions represent what. Now, if y was equal to 0, and this is a function, then these would be the point negative 4, 0, and negative 5, 0. So what we found are the x-intercepts. So here I've graphed it, and you can see clearly the x-intercepts. I actually gave it to you as an equation and as a table, so numerically, and you can see that those are my x-intercepts. We've been working this week a lot too on this parabola, so let's just review here that the vertex has to be directly in the middle of them. So you can see that that x-coordinate of the vertex is negative 4.5 because it's right in the middle. Now the y-coordinate we don't quite know yet. We're going to be talking about how you could find that, and I want you to think about that a little bit. But again, when we solve a quadratic equation, we are finding the x-intercepts. All right, but now let's look at it in vertex form because we've been working on graphing in vertex form. Okay, so first we have to set y equal to 0. Okay, so I'm going to do that. So 0 equals x minus 2 squared minus 9. Okay, then isolate the square. How do you isolate the square? It means get this entire thing by itself, okay? Get that entire thing by itself. That's the square part. Okay, so I'm going to do that by first adding 9, and I get 9 equals x minus 2 squared, okay? Then we're going to take the square root of both sides. I'm going to call it the SR of both sides. So when I do that, I'm going to take the square root of both sides, remembering that when I take the square root of both sides, I have to consider the absolute value of that number. So that would mean I have to look at both a positive and a negative 3. You don't want to forget that. Okay? And then solve for x. Okay, and again, don't forget positive, negative. And I'll do that for step 3. Don't forget plus minus. Okay, all right, so I'm going to bring the 2 over. I always like to put it in front of the plus minus, so I'm going to put it right there. And then I'm going to do x equals 2 plus 3, which in this case would be 5, and x equals 2 minus 3, which would give me negative 1. So my x-intercepts are 5, 0, and negative 1, 0. Okay, so think about that, okay? All right, now I want you to try this one. Y equals x minus 3 squared minus 4. So go ahead and press pause and come back and I'll go through it. All right, so you're back and I set y equal to 0. I brought the 4 over. I took the square root of both sides, remembering that when I took that square root, I'm going to both consider the positive and negative 2. And then I isolated the x, or I solved for x, so I brought the 3 over, putting it in front of the plus minus, and then again isolating. So that would give me 3 plus 2, which is 5, and that would give me 3 minus 2, which is 1, and then I'm going to write them as the coordinate points for the x-intercepts, 1, 0, and 5, 0. So hopefully you can kind of see that. All right, more of a challenge when I put a number in front of the square. So watch me here. I'm still going to set y equal to 0. I'm going to isolate x, but now I've got to follow the proper order if I was solving. So I'm going to subtract 2 first, giving me negative 2 equals negative 2x minus 1 squared. And then that negative 2 that's being multiplied to the square, I actually need to divide that to both sides. Okay, so that's going to give me 1 equals x minus 1 squared. Now I can solve by taking the square root of both sides. Now let's remember, when we take the square root of 1, the square root of 1 is 1. So I would have a plus or a minus 1, because when we take the square root, we have to consider the absolute value of the number. All right, so then that would leave me x minus 1. Lots of 1's here. I'm going to add 1 and I'm going to put it in front of the other number. So I have x equals 1 plus 1 and x equals 1 minus 1. So 1 plus 1 is 2. 1 minus 1 is 0. So my x-intercepts are 2, 0, and 0, 0. Yes, the origin can be an x-intercept. We're going to talk more about these x-intercepts a little bit later. All right, there's one other thing that can happen. What happens if the square root isn't a perfect square? Now, I'm going to be spending time in class doing this, so don't panic if you don't follow, okay? All right, so I'm going to still set y equal to 0. I'm going to bring the 12 to the other side. Okay, and then I'm going to take the square root of both sides. Okay. So I do have plus or minus the square root of 12 equals x plus 1, okay? And then I'm going to bring that 1 over. I'm going to put it in the front, so it's negative in this case. So my answers are actually negative 1 plus root 12 and negative 1 minus root 12. That's yucky. Well, root 12 can actually be simplified, okay? So how do we simplify root 12? Well, we want to break it up into perfect squares, or any perfect square that's a factor of 12. For example, I can rewrite the square root of 12 as the square root of 4 times the square root of 3. So in a simpler form, this would be 2 rad 3, or 2 root 3. So my answers would be negative 1 plus 2 root 3, and x equals negative 1 minus 2 root 3. And we're going to talk more about that in the coming weeks. And I am going to be showing you how to do this tomorrow in class. We're going to be talking it through. But for now, I just want to make sure you feel comfortable with solving a quadratic in Vertex form to find the x-intercepts. And again, we're going to go over simplifying radicals tomorrow in class. Have a wonderful day.